Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at something called the rational roots theorem. This theorem is going to allow us to work towards taking a polynomial that is in standard form and using the tool of synthetic division to take it and put it into factored form. When a polynomial is in factored form, it's much easier to graph or find its x-intercepts or any of a number of things we might want to do. Now with synthetic division, we can test potential factors to see if they are roots by checking for a zero remainder. But if we just guess and check, we might be guessing numbers that couldn't even be roots. So what we want to do is narrow down our focus by listing out the possibilities, the possible rational zeros, and only testing from that list. So, the list of all possible rational zeros will come in the form plus or minus p over q, where p is the list of all the factors of our constant a0. So our constant term is the one that doesn't have any powers of x, and so we're going to look for all the factors that go evenly into that constant, and that will give us our list of values in our numerator, or our p values, over q, which is all the factors of the lead coefficient a sub n. So our lead coefficient is the coefficient of the term with the highest power of x, and so we're going to look for all the factors of that lead coefficient. Now I know that can feel a little bit like, wait, what? So let's look at an example, and I think it will be pretty clear. So here's an example. Let's list all the possible rational zeros of y equals x cubed minus 43x minus 21. So we are going to find our list by taking plus or minus p over q. Remember that p is our list of factors of our constant. So all of the numbers that can be used in a multiplication problem to get 21. So just thinking through that, 21 ways I can get that. I can do 1 times 21, or I could do 3 times 7. So those are all the integer pairs that can be used to multiply to get 21. So I'm just going to list those out, and I like to put them in numerical order. So that's going to be 1, 3, 7, and 21. So those are all the values in my p list. For q, we're going to do the same thing, but we're going to look at factors of our lead coefficient. In this case, because we just have x cubed, our lead coefficient is an understood 1. Now the only ways to get 1 are 1 times 1, and since that's a repeated factor, we only need to list it one time. So now that we have all of our possible factors for our constant, or p, and all of our possible factors for our lead coefficient, or q, we can go ahead and separate those. So that's going to be plus or minus 1 over 1, which is 1, plus or minus 3 over 1, which is 3, plus or minus 7 over 1, which is 7, and plus or minus 21 over 1, which is 21. So that means if we split up the plus and minus, we have 1 and negative 1, 3 and negative 3, 7 and negative 7, 21 and negative 21. Now, while that's still 8 values, what we find is that if there are rational zeros of this polynomial, they must come from this list of 8 numbers. So we don't want to check values like 2 and negative 2. We know they're not in our list of possibilities. We don't need to check them. So there's that one. Let's look at another one. Same instructions here, but let's see what happens if we don't have 1 as one of our p or q values. So listing all the possible rational zeros here, again, coming from the form plus or minus p over q, p will be all the factors of our constant. All the ways to get 8 are 1 times 8 and 2 times 4. So listing those out separated by a comma, that would be 1, 2, 4, and 8 over q. Q is all the factors of 2. So that's 1 times 2. So listing those out, 1, 2. So now that we have something other than just 1 in the denominator, let's look at how this works. We're going to list every value of the numerator over each value in the denominator. So that's going to give me 1 over 1, which is 1, and then 1 over 2. Okay, that takes care of 1. Now same thing here. That's 2 over 1 and 2 over 2. So that takes care of 2. Do the same thing with 4. 4 over 1 and 4 over 2. And then finally 8 over 1 and 8 over 2. So each value in the numerator gets paired with each denominator. From there, we want to go ahead and simplify where we can. So 1 over 1 would be 1, and then 1/2 can't be simplified. 2 over 1 is just 2. 2 over 2 is 1, which is already listed, so I don't need to list it again. I'll just drop that one off. 4 over 1 is 4. 4 over 2, well, that's 2, but I already have that in my list, so that one's taken care of. 8 over 1 is 8, and 8 over 2 is 4, but again, I already have that one in my list. So there's my list of all possible rational zeros. So it could be positive or negative 1, positive or negative 1/2, positive or negative 2, positive or negative 4, and positive or negative 8. Those are the only rational numbers that could potentially be zeros of this polynomial. To see how to check if these are polynomials, join us in our next video on the rational roots theorem.